This is question 9 of the OCR 2010 C1 paper, and the question says, given that f of x is 1 over x minus the square root of x plus 3, find f dashed of x. Well, f dash of x is the same thing as dy dx, really. It means you have to differentiate. And if you're going to differentiate something with x's in, you really need powers on the x's rather than 1 overs and square root signs. So I'm going to rewrite the question first of all. Instead of writing 1 over x, I'm going to write down x to the minus 1. And here, instead of writing the square root of x, I'm going to write x to the power of a half. And I'm still going to have my plus 3. So that line and this line here are equal to each other. They're just written down using different notation, different ways. I've written it in powers because that's what I need to be able to answer the question. So now I need to differentiate. That will give me my f dash x. And to differentiate, the power comes down the front, is multiplied by the x, and then you knock 1 off that power. Same thing will happen here. That power comes down the front, is multiplied by my x, and I knock 1 off the power. When I knock a whole 1 off a half, I get to minus a half. And if I differentiate a number with no x's, it disappears. So I can get rid of my 1 here if I want to, and I can just write down minus x to the minus a half, x to the minus a half. And that is absolutely fine as the answer. If you wanted to, you could rewrite this without a minus power and without a power of a half. There's no need to do it. If you wanted to do it in the question, and you do need to understand that you could do this. The minus means 1 over, so I could write the first bit down like this. And here, again, the minus means 1 over, and x to the power of a half is the same as square rooting. So I could, if I wanted to, have written my answer down like that. It wasn't necessary, but I could have done if I wanted to. The next part of the question, they're asking for f double dash 4. This is a second derivative, so it's the equivalent of d2y by dx squared when x is replaced by a 4. So I need to work with the line at the top of the screen, this line here. This is my first derivative, and I need to differentiate that again. So I'm going to write that line down, and I need to work with the line where there are powers on my x's. And if I differentiate this again to get the second derivative, I bring my power down and multiply by what I've got. So the minus 2 and that minus sign will just make a 2. And I take 1 off that power, that takes it down to minus 3. Then over here, this minus a half comes down as multiplied by this minus a half, which makes plus a quarter, and I take a whole 1 off this number up here, this power. If I take a whole 1 away from minus a half, I get down to minus 3 over 2. So that's my second derivative. Now in a minute I've got to replace my x's with 4's. And actually this time it is useful, I think, to rewrite this without the minus powers and things. 2x to the minus 3 is the same as 2 over x to the 3. That minus sign there means I could write the x cubed on the bottom of the fraction. And over here, I've got my quarter, and because my x has a minus power, I can write it on the bottom with the power there of 3 over 2. Let's just think a minute what the power of 3 over 2 means. That's the same as x cubed to the power of a half. So if I times those powers together, that is what I get. The power of a half is the same as square rooting. So that's the same as x cubed square rooted. So I could rewrite this bit on the right over here as 1 over 4 lots of cube root of x square rooted. And now what I've got to do is replace my x with a 4. So I get 2 over 4 cubed plus 1 over 4, and inside here 4 cubed all square rooted. 4 cubed is 4 times 4 times 4 is 64. So over here I have 4, and then here the square root of 64. So 2 over 64 is the same as 1 over 32. And over here, that 64, once it's square rooted, is 8, and 4 lots of 8 is 32. So I get another 1 over 32, add those together, 2 over 32, or 1 over 16. And that 1 over 16 is the final answer to question 9.